In this video, we're going to explore how to find horizontal asymptotes. Horizontal asymptotes are dotted horizontal lines on a graph. So, we're looking at something like a horizontal line that's dotted, and just like with vertical asymptotes, the graph will get close to a horizontal asymptote. In other words, it will get parallel to that horizontal asymptote on one side of the graph or the other. Essentially, the horizontal asymptotes are what we would call the end behavior of a rational function. We want to know what the arrows are doing to the very far left and very far right of that rational function. How do we determine what the horizontal asymptote is? The horizontal asymptote is determined by what we call comparing degrees. We are going to determine what is the degree of the numerator, what is the degree of the denominator, and then we will compare those degrees. We have three possibilities, or three cases. Case 1 is if the degree of the numerator is smaller than the degree of the denominator. If that is true, then the horizontal asymptote will always be exactly y equals 0, which represents the x-axis. Case 2, if the degree of the numerator is exactly the same as the degree of the denominator, then we will form a fraction of the leading coefficients. So the answer will be the horizontal line y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Case 3, if the degree of the numerator is larger than the degree of the denominator, then there is no horizontal asymptote. So we will use this chart to determine the horizontal asymptotes of the following examples. So for part A, we have f of x equals -3 divided by x plus 1. We want to find the degree of the numerator, and we want to find the degree of the denominator. The degree of the denominator, we want to remember that degree is determined by, if we have terms, it's the highest exponent that we see on that term. So for part A, we want to determine the horizontal asymptote of this rational function. To do that, we're going to compare degrees. We want to find the degree of the numerator, and we want to find the degree of the denominator. We want to figure out which one is larger. So, in the denominator, if I'm looking for the degree, so degree of x plus 1, it's written out as terms. And if it's written out as terms, then the degree will be the highest exponent that I see on x. So the degree of the denominator is 1. We want to be careful about determining the degree here at the top. Remember, degree is the highest exponent that you see on x. If you do not see any x's, then the degree is always 0. So that's degree 0. This represents what we would call case 1. The numerator degree is smaller than the degree of the denominator. So in this case, the horizontal asymptote will be exactly the x-axis, or y equals 0. Alright, for part B, we want to determine the horizontal asymptote. So we will compare degrees. The degree of the numerator would be 2. The degree of the denominator, in this case, would be 4. The degree of the numerator is smaller. So in this case, we would call this case 1, and the horizontal asymptote would be the horizontal line y equals 0. That's also the same thing as the x-axis. So we want to remember that we are using this table to determine horizontal asymptotes. In both part A and part B, the degree of the numerator was smaller than the degree of the denominator, so the result was that the horizontal asymptote was y equals 0. So you're going to need to know this table. Okay, so you'll need to memorize that table. Okay, part C and part D. We want to figure out what is the horizontal asymptote. So we will need to figure out what is the degree of the numerator and what is the degree of the denominator. The degree of the numerator will be 2. The degree of the denominator is also 2. We want to compare them. When we compare them, we see that they are the same. If the degrees are the same, this is case 2. In order to determine the horizontal asymptote, you will have y equals, we will form a fraction of the leading coefficients. The leading coefficient in the top is 21. The leading coefficient in the bottom is 7. We always reduce our fractions if possible. 21 divided by 7 is 3. So the horizontal asymptote will be the horizontal dotted line y equals 3. For part D, we want to determine the horizontal asymptote, so we will determine the degree of the numerator and the degree of the denominator and then compare them. The degree of the numerator, the highest exponent that I see on x is 1. The degree of the numerator, the highest exponent that I see on x is also 1. So in this case, they are the same. We would call this case 2. If we have case 2, then we form a fraction of the leading coefficients. The leading coefficient in the top is -5. The leading coefficient from the bottom is +6. So our horizontal asymptote will be the horizontal dotted line y equals -5/6. So once again, we are using the table above. In parts C and D, the degree of the numerator was exactly the same as the degree of the denominator. So to find the horizontal asymptote, we form the equation y equals the number from the top, that's the leading coefficient, the number at the bottom, that's the leading coefficient. We always reduce that fraction if possible. What if the degree of the numerator is larger than the degree of the denominator? Then we would say that there is actually no horizontal asymptote. This will be exhibited in parts E and F. In part E, we are looking for the degree of the numerator and the degree of the denominator. The degree of the numerator is 4. The degree of the denominator is 4. In part E, we want to figure out what is the horizontal asymptote. So we will determine the degree of the numerator, which is 4. The degree of the denominator is also 4. Since they are the same, we are in case 2, we will form a fraction of the leading coefficients. So the leading coefficient at the top is 5. The leading coefficient from the bottom is 2. There is no common factors. That fraction does not reduce, so our final answer would be y equals 5/2. Remember, this represents a horizontal dotted line on my graph. For part F, we want to determine what is the horizontal asymptote. To determine the horizontal asymptote, we will find the degree of the numerator and the denominator. Both are still written out as terms. The degree of the numerator is 3. The degree of the denominator is 2. In this example, the degree of the numerator is larger. So this puts us into case 3, where there is no horizontal asymptote. Once again, to determine these horizontal asymptotes, you will have to memorize this chart. How do we determine horizontal asymptotes? We compare degrees of the numerator and the denominator. Once you've compared the degrees, is the numerator degree smaller, the same as, or larger, then that will put you into different situations. So you will need to know this table to determine what the horizontal asymptote is after you've compared degrees. What's the resulting horizontal asymptote for each of those cases? One thing to note is that a graph may cross a horizontal asymptote, but we've already stated that a graph may never cross that dotted vertical line that we call a vertical asymptote.